when do we stop this infinity? So my intuition, which might be wrong, but it's shared with the community, is that h bar gives you granularity in state space. So there are things that cannot be resolved that are smaller than that volume. So that's Heisenberg uncertain principle. So what that means is that you can start calculating these solutions, but they're actually only good up to some volume of h bar to some power. Not sure what its important power will be, because this is embedded in infinite dimensions, I'm not sure. And what that means is that as I put more and more of these solutions, it turns out that as you go look at longer and longer time, and we also know that this landscape gets more and more complicated. We know that there are exponentially many more solutions as the time increases. So there are more and more hills, so, if you go in, and they get thicker and thicker, etc. But now, they should be fuzzed out by this h bar. So this should stop at some point. At some point, you'll just have a landscape in which you cannot produce an extra little peak or hill because it's smaller than your volume h bar. So these are the elements, the last one I didn't discuss, but the last one we try to understand by looking not in 1 over h bar, but when looking 1 over sigma, where sigma is stochastic noise, because we have much better intuition about noise than I over h bar, but we also have lots of experience where, I over h bar is making time imaginary. So there is a relation between statistical mechanics and quantum mechanics, which is sometimes works called weak rotation, where you work in a imaginary real time, and mathematics is the same. So this might be helpful. So this is the grand scheme, and I will leave it to you to fill it out. If you don't know when the thing is due, the project, it implies that you haven't looked at the homepage of the course since the beginning, because it's always been there. And it's still there, and it's always the same date. So click on the course homepage and find it.